Welcome learners for the lecture 20 of a differential geometry. Today we will discuss about the theorem that will be depending on the parameters of a surface. Okay, previous lecture we explaining to the definition that is a surface in a parametric way for the orthogonal properties. Okay, the parameters on the surface can always be choose so that the curve of the given family and orthogonal trajectory become a parametric curve. What will be explaining parameters means we uses and this form, that is a uv is also given as a parameter. C is a constant form, they created as a parameter, but other uv phi xi it is show that to the parameter for explaining to the surface that always be the curve of the given family. Any family will be given, they generated as a curve and the orthogonal trajectory become a parametric curve. Okay, let us go started as a let the given family phi uv equals to c of the curve be given to the differential equation. Okay, p du plus q dv equals to 0. This is the first equation. Then there exists in a integrating factor, that is a lambda equals to lambda uv is not equals to 0. P getted as a value, that is a lambda phi 1. Q getted as a lambda phi 2. Lambda is a constant because they does not get it as a lambda 1 and lambda 2. Then orthogonal family generated as a xi, that is a uv equals to k of the given family is the solution of a fp minus eq du plus gp minus fq dv in this form equals to 0. How to given as a equation? PQ in both of this form, it will be generated in this form. This is getted as a there exists an integrating factor mu, that is a uv is not equals to 0, so such that f of p minus e of a q du not getted only as a form mu consider as a phi 1. How? Gp minus consider as a form EQ equals to mu phi 2, phi 1 equals to del phi upon del u and phi 2 equals to del phi upon del v. Both of this equation will be generated only as they are a independent variable will be changes to the form in a upper limit. Okay, then del phi xi upon del uv, they noted as a matrix form that will be formed del phi upon del u. Row will be consider first u and second as a v, and second row consider u and a v, that will be the xi and phi will be changes. Then put it to the value p by lambda q by lambda, that is a 1 by mu fp minus eq and 1 by mu gp minus, okay, this is not a eq fq. Then cross multiply in this form, 1 by lambda mu is a constant in both of this form, p gp minus fq minus q minus eq in this form. Then 1 by lambda mu is a constant, they get it as a value if eg is greater than 0 and eg minus f square is greater than 0, so that equation 3 is a positive definite quadratic form. P and q do not vanish to the form. Okay, eq square minus 2fpq plus gp square is not equals to 0. This show that del phi and xi upon del uv is not equals to 0. Proper parametric transformation, that is a u dash equals to phi uv and v dash equals to xi uv transform to the family of a curve, that will be generated as a phi uv equals to c, and orthogonal family is considered as a family of a curve is generated as a phi, and orthogonal family is considered xi k. Paraboloid x square minus y square equals to z. Find the orthogonal trajectory of the sections by the plane z is a constant. The parametric representation of the surface can be taken as x equals to u, y equals to v and z equals to u square minus v square. Hence the position vector of a given point on the surface is r equals to uv equals to uv u square v square. Since we are concerned with the sections by z equals to constant, the first family of a curve is given phi u equals to u square minus v square equals to constant. Then put up to the value the tangential direction at the any point on the surface first will be given, that is a minus phi 2 phi 1 equals to 2v 2u, or we can say it is a v and u. If du upon dv is the direction ratio of the orthogonal direction at a uv, we get from the condition of orthogonality, that will be changes to the form ev du plus f u du plus v dv plus gu dv equals to 0. This will be getted as a form. Let find E, F and G. R equals to 1 0 1 0 2u and R2 equals to 1 0 minus 2v. Hence E equals to R1 into R2 1 plus 4 mu square. F equals to R1 into R2 minus 4 uv and G equals to R2 into R2 1 plus 4 v square. Then using to the equation 2, that is putted all the value, then equation to the part and simplifies v du plus u dv equals to 0 or duv equals to 0. Integrating equation 4 and we get u equals to constant, which gives the family of a orthogonal trajectory. This will be fine.